Okay, yeah, okay, it was on mute. All right. All right, hello everyone. My name is Alex. Welcome to my talk about AI coding agents and how to code them. Now, throughout the talk, I will be interchangeably using AI coding agents and AI agents from time to time. And they are pretty much, for the sake of this presentation, they are interchangeable just because all the techniques, all the code, which I will show later throughout the presentation, is applicable to essentially both AI coding agents specifically and AI agents in general. Now, a few words first about myself. So the QR code on the left is for my contact details if you want to reach out after the talk. But yeah, I've been working in IT, mostly in machine learning and ops for more than 10 years now. I've been working as part of the company called Encoder, which is developing coding agents, coding assistants, agentic coding assistants from essentially the first day. And then for the last year, I've been mostly doing DevRel, which resulted in quite a lot of flights over the just this past year. And I also have 4 Maine Coons, which I sometimes get the chance to visit between my events. And yeah, this conference for me is event number 32 essentially. Now, this conference and like many others is full of talks about AI, and I hope you don't feel like this coming into the last talk of the day again about AI. And yeah, hopefully you won't be overwhelmed by talks about AI and ChatGPT and whatnot. And at the same time, you also can find a lot of headlines in the news similar to this, that AI will soon replace developers. Like this one is for Mark Zuckerberg. I think he said that AI will replace mid-level engineers by 2030, I believe. And those headlines are, well, they are popping up pretty much since Copilot went public, right? But lately they started to pop up more often, and there are two main reasons for this. Well, apart from hype and whatnot. First of all, of course, the models are getting better, right? So this is a comparison of a few of the most recent models, like GPT-5, Gemini 2.5, and a few Anthropic's models. And I highlighted here 2 coding benchmarks, which are probably the most important for us for today's talk. And while, of course, on benchmarks, models tend to become better and better, it doesn't necessarily translate one-to-one to real-life world. And the reason for that is, well, LLMs are trained essentially to predict the most probable next symbol or token. And sometimes this can lead to mistakes just because something that is most common, most probable, doesn't necessarily mean that it is what you wanted, right? So, and LLMs are good at finding patterns, but unfortunately, LLMs are not really bound to, to real understanding of the world. Sometimes it causes these kind of weird suggestions, but I guess it makes sense given the art AI has been producing for us. Now, jokes aside, so the agenda for today, and the second sort of part of these headlines is AI agents, right? So we will talk first about what agents are in general, sort of in theory. Then we will switch to sort of the main part of this talk about how to create your own coding agents, how to create your agents in general. And I will go through several steps, sort of increased complexity or abstraction, if you will. And then we will briefly talk about the future of software development and how it is being shaped by AI nowadays. Now, first of all, let's define what is an AI agent. Now, I think there were already a couple talks today about AI agents, but just to be sure that we are all on the same page. So we can define AI agent as a software that performs tasks on behalf of a user. Now, on its own, this definition essentially sounds like any software, right? So any software, like any, for example, coding assistant, performs tasks on your behalf. So it can generate code, it can, potentially fix errors, generate documentation, and so on. So you can tap, and get a bunch of code which you will need to then try to understand what the hell is going on. Now, the main difference of agents from the sort of classical software is that agents follow a few agentic patterns or principles, if you will. And first one is tool use. So agents essentially, well, LLMs can use tools which you give access to. So that can be any tool starting from access to file system. It can be running bash commands. It can be some execution of the code. It can be web search. So essentially any tool which you give access to LLM, it can use to get more context to give you a much better answer, or to validate its own code, for example, right? So let's say LLM generates the code, then given the access to Bash or Python or C# compiler or whatever, it can compile the code, check if there are any errors, and then fix them to make sure that the code actually works. Then LLMs or agents can also do planning, so they don't just blindly output the next tokens, right? They can do some sort of pre-planning steps. And if you've used recently ChatGPT, or like GPT-5 or Claude, you might have seen those sort of thinking steps, right? So where LLM is trying to sort of think about the task, what steps it needs to take, or what steps it requires to do in order to give you the answer. And this is sort of like a planning step. And ideally, agents can follow this plan, this outlined plan, and then they can also reflect, right? So this is the third pattern. They can also reflect on their work, or they can reflect on the work of other people or other agents. And this is where we go to multi-agent collaboration, where basically multiple agents can work either together or against each other in order to achieve the goal, basically. And you can think about AI agents as sort of Roomba or robot vacuum cleaner, right? So software itself on the robot vacuum cleaner is an AI agent, and its task, its goal is to clean the room, right? But the software itself can't do that. It needs tools, right? So for example, there is, of course, the brushes, the wheels, right? The brushes, the wheels, and the vacuum cleaner also do some planning. Now, ChatGPT thinks that robots move around in this weird shape pattern, but yeah, I guess in reality, they try to move in a more optimized manner. And unfortunately, or fortunately, there is still no multi-agent collaboration for vacuum cleaners, unless you count this as a sort of multi-agent collaboration. But maybe in the future, they will be able to somehow talk with each other, with other appliances, and whatnot. Now, if we translate this to sort of real world and how it affects the LLMs and the accuracy of their predictions, we can see that, for example, here from the recent GPT-5 release, we can compare the result on one of the benchmarks, Humanity's last exam, with GPT-5 without tools and without thinking. So it is 6.3%, versus with thinking and Python and web search, it got to 35%. Right, so it's pretty high boost only from essentially two things, right? Tool use and thinking or planning. So you can already see how those just two tools can significantly increase the accuracy, the quality of results, and so on, compared from vanilla LLM. And if we sort of move this to like coding example, we can essentially get the following patterns. So let's say the task is for agent, for LLM, to get the designs from Figma and update our website based on the updates in the designs. All right, so for this, the agent can first, of course, decide to use tools. So it would use a Figma tool to get the designs. It then do some planning step to see which files it needs to update, which changes it needs to do, and so on. It will generate the code. Then it might decide to run the browser, right? So for that, it can use another tool, right? So it will run the browser, run the website, maybe get a screenshot of the page, compare it against the designs. So there is a reflection, right? And then based on this, it might decide to maybe update something or maybe create a test. And again, repeat this step over and over until it is satisfied, hopefully satisfied with the result, and hopefully us as user also satisfied with the result. So this is sort of like a theory of what agents are and how they differ from sort of classical LLMs, vanilla LLMs, and software, right? And now let's finally do some coding. So all of the code which I'll be showing today, is available on this repository over here, this QR code. So if you want to play around with it after the talk, or if you want to use it as a sort of starter for your own project, feel free to fork it and play around. Now, the code itself is structured in sort of several, as I mentioned, in several sort of levels, right? So we will start with some baseline, which will be a vanilla LLM, and then we will gradually implement different agentic patterns, agentic features, all the way to multi-agentic system. So let me switch to my code over here. All right. So as I mentioned, we will start with a baseline, and let me also zoom in a bit so that everyone can see. So yeah, we will start with the baseline, and in this case, the baseline will be essentially just a simple vanilla LLM. I will be using GPT-5 for this example, and you probably had similar experience if you used GPT-5 or whatever, right, through API. So on its own, the model doesn't have access to any tools, any web search, any browser, whatever. So if we try to ask GPT or any LLM for that matter to let me execute all of this. Yeah. So if we ask LLM to about something that requires access either to physical world, right, or to my local machine, it essentially fails, right? So if we ask it about the response time for Google, obviously we as developers we could do just ping command, right? But LLM obviously doesn't have access to its to environment, to Bash or whatever. So in our case, yeah, it did provide some helpful examples, right? Some helpful commands and some typical numbers. But this is not really what we wanted to get, right? We wanted to get the actual value, not the sort of average or typical results. The same goes with the Python packages. So obviously LLM on its own doesn't have access to my local machine, so it won't be able to give me any actual answers. It did provide some commands, some helpful commands, and interestingly, GPT-5 is more focused in that regard. So previously, for similar tasks, I used GPT-4, and you can also plug here GPT-4 and or GPT-4.1, for example, and it would be more convoluted answers. Now GPT-5 is a bit more sort of focused. And then, yeah, so what's new in Python 3.14? So as you might know, LLMs have some knowledge cutoff. So basically, that's the date until when they had the data, right? So they usually trained on a large corpus of data, which sort of cuts off at some date. So I think, yeah, it mentions here that its cutoff date is October 2024, right? So it doesn't know anything beyond that date. And Python 3.14 was, well, I think it's still not released. So obviously it doesn't know much about this release. It did see probably some release candidates. So from that, it could get us some answers, right, over here. But obviously, this is, again, not something that we wanted to get, right? So if we, let's say, wanted to use some new version of the framework with our coding assistant, it needs to have up-to-date knowledge, and we obviously can't retrain the model every time, like every day, the new data comes in, right? So while it is still kind of helpful, right, it provided some comments for us, it provided some possible answers. It wasn't very helpful in real-life applications. Now let's see how we can enhance this just by giving it the LLM a few tools. So let me close this one, and let me open our second sort of level of agents. Now here, I will be, again, using GPT-5, but on top of that, I will be using what is known as React framework. Now, React stands for Reason plus Act, and let me execute this cell. So Reason plus Act framework means that we are essentially instructing LLM to go through a loop of several actions. So first is the thought. So LLMs needs to think about if it needs to perform some action to gather more context, or if it knows answer right away. Then, if the action is needed. The second step is the actual action, right? So then there is a pause where the action is supposed to be actually executed to gather some context. Then we go to observation step, where LLM essentially observes the response from the tool. It could be, again, the ping, it could be some web search, and so on. And then hopefully that would be enough for LLM to give us the answer, or if not, this loop continues on and on until the LLM gets the answer, or we sort of hit the loop counter limit. And we can quite easily implement this through this sort of system prompt, which essentially defines what I just described, right? So you are running in the loop of thought, action, observation, and pause and observation. And we also define a few tools right in the prompt, right? So we provide a few tools, namely ping. So we define ping as, and we also provide an example on how to actually, for LLM, how to sort of call this tool, right? So it's ping, semicolon, and then the website. We also provide access to bash tool, which is, in this case, will execute any bash command, right? And there is also a description for each tool. And we have the web search, which will do the web search. We also provide an example session, right? So an example would be we, as a user, pass on the question. So how many islands make up Madeira? Then LLM might decide that it doesn't know the answer right away, so it might decide to use a web search. It will call the action web search, get the result, and then, based on this observation, it will give us, hopefully, the right answer. So let me execute this. And then we also define our tools on our own, right? So here, the tools themselves are pretty simple implementation, pretty straightforward, right? So there is ping, as I mentioned, there is bash, and there is web search. They all are, the most straightforward things here. There is no, there is no frameworks. It just gets the context and that's it. No filtering, whatnot. And we will see the better ways to implement tools in a second. But for now, let's actually verify that they all work. So ping seems to be working. By bash execution works as well. And then web search should give us, okay, web search. Web search is not working. Okay, well, let's see. I'm not sure what's up, but it should be able to use the other actions. Right, so then over here, we are essentially just implementing the React loop, right? So we start with the system prompt, which I just shown, and we add to it the user query, the user prompt over here. And then we go into the loop of React framework, where we first query the model, right? Then the model decides if it needs to perform some action. We detect this action based on the regexp. If there is action, we actually execute that action, right? We pass on the observation to LLM. And then based on this observation, hopefully LLM will be able to give us the answer, or it might go to another loop. Right, so let's execute this, and let's see what's the response time for Google. So in this case, LLM hopefully should, so as you can see, decided that it needs to run the action ping, right? So it decided to ping Google.com. It got observation, which is essentially the result of running this tool locally on my machine. And then it got the answer for us, right, based on this observation. Same goes with the Python packages. So it should hopefully decide to run some bash command, one of those which previously it suggested for us. So indeed, it decided to use this python-m peep list, yada yada, which gave it quite a long list of Python packages, which I have installed locally. And it will take some time for LLM to sort of proceed to process this long input, but in the end, it will give us essentially the answer. And I will probably won't be running web search because there was some issue with the web search previously, but it would pretty much be the same. It would do the web search and then summarize essentially for us what it found. Right. Let's see if it will give us finally the summary of this. It sometimes takes a bit longer because either the internet connection is a bit slow, but also the processing can be quite long for long inputs like this one. coffee, and laptop, what could go wrong? All right, well, it looks like it doesn't want to summarize anything for us. Hope the internet connection is still working. Well, yeah, I hope you will believe me that it will, basically summarize it at some point. But yeah, I'm not sure what's. I hope the GPT-5 doesn't have any issues on the server as well, because it would be quite a bummer. All right, but yeah, as you've seen here previously with the bash tool, with the ping, probably the simpler one because it's not a lot of input tokens, right? So it got decided on the action. Use this action. We as a client, not as a user, ran this action, and then LLM was able to essentially respond based on the observation. And yeah, I'm not sure why it's taking that long. It's usually not that long. All right. Well, now tools, as you've seen, we define the tools essentially just like this, just like functions, right? So obviously, in my case, with this implementation is rather simple, right? So I mean, as you've seen, web search actually didn't work. It worked like an hour ago, but I'm not sure what's happening now. But as always, so as you would imagine, there are better ways to do a web search. There are probably better ways to do ping or execute bash commands. Like here, I'm not doing any sanitation, any security checks, whatnot. So obviously, it's not very production-ready solution. Right? So let's say someone else decided to implement another tool for web search, which would do some summarization, which would do some linking and so on. And we would want to change our tool, our web search tool, to this other new web search tool. Right, so in this scenario, we would need first to update the prompt. Right, so we might also would need to update the way we process the inputs and outputs, because the tool might change the input schema, the output schema. So it's not very, it's not like drag and drop kind of thing, right? It might be a bit tricky to update the tools which we define ourselves. Now, luckily, of course, there are a few ways to sort of standardize this. And the most common being, let's see if it did actually the thing. OK, so after a lot of thinking, it actually got to the answer. And in this case, it just, output the same list. All right. Yeah, and yeah, it suggested to filter something, but yeah, OK. It took a long time to, I guess, output the same list. All right, so as I mentioned, there are a few ways to sort of standardize the way we can use tools and the way we can pass on tools to LLMs. The most common one is MCP. It is introduced, model context protocol. It is introduced by Anthropic, I think, in the end of last year, right? And it is essentially, let me start the slideshow. So MCP, or model context protocol, it is essentially a standardized protocol for providing context to LLM, or essentially to do a tool calling, if you will. So it is based on JSON RPC, so it is essentially standardized inputs and outputs. And this allows, first of all, for LLM to get the structured information about how to use the tool, which tool does what, and so on. And then the same goes for the output. It is in the structured format, so LLM knows sort of what to expect, and it is formatted in a way that is easy for LLM to process. And MCP contains of essentially a few main components. First one being MCP client or MCP host, which could be the ID, basically anything which runs the agent, the LLM, right? So that's MCP host, MCP client. And MCP client is essentially just querying the MCP server for the tools and for the context from those tools. Then the second part, the MCP server, essentially is responsible, first of all, for defining the list of tools and its structures, and for inputs and outputs, how to call them, how to use them, and so on, and for advertising those tools to the client. And then the second part of responsibilities of MCP server is to essentially do those tool calls, right? And as I mentioned before, those tool calls can be pretty much anything. Whatever you can program, you can transform into MCP tool, into MCP server, and it can be access to local resources like file system, bash tool, and so on. And it also can be access to remote resources like, for example, Jira, web search, Confluence, whatever, right? So whatever you can program, and again, whatever you can query through, and for example, RESTful API or gRPC, whatnot, you can convert into MCP server and allow LLM or agent to get more context from those tools through the MCP server. Yeah, so if we essentially look at how it works between us, the user, the LLM, the client, the server, it follows the following schema. So first, the client and the server, they sort of do a handshake, right? So the server, the client initializes connection, and then the server advertises its capabilities. So it essentially sends a list of tools which it is able to use, to execute, and how to call them, what they do, and so on. Then, whenever the user asks something from LLM, and LLM decides that it needs to gather more context, right? So, but then it needs some external data, it can, use an MCP client, request the call of specific tool, which then, as I mentioned, it's basically standardized inputs and outputs. It will send the request to the server will execute that tool, return the output, and then LLM essentially gathers extra context to give you a proper answer, well, hopefully proper answer, to give you better code generation, whatnot. So basically, it is a way for model to gather more context, which is not otherwise available for LLM. And there are quite, So before we go into the example, so yeah, this is an example for actual tool, right? So this tool is for creating branches in Git. And as you can see, it takes 4 inputs. 3 of them are required. So it needs owner, repo, and the branch, right? And there's optionally from branch, which by the defaults to default branch. And yeah, essentially, this is attached to the prompt, which is sent to LLM, and then LLM can decide, depending on its task, if it needs to call this tool or other tool, or it doesn't need to call anything at all. And there are a lot of different tools already available, a lot of MCP servers. So on the left, you have a lot of URLs for different registries, right? So there is sort of the main, or the first one, MCP registries from the Anthropic itself, the model context protocol / servers. We as Encoder also have a marketplace, which is available right inside the IDE. And there are also a lot of third-party MCP registries, like, for example, mcp.so. And as you can see, the MCP servers can be for pretty much anything, right? So it could be some IT-related tools, like, for example, Grafana or Exa as a web search. So essentially, there are probably now already thousands of MCP servers which can give LLM access to a lot of different contexts. Probably the most unusual one which I've seen is for Dutch railway system. So essentially, it would allow LLM to query API for Dutch railways, and then it could get the latest trains schedule and whatnot. So I couldn't make it work, unfortunately, but it is something that you can basically do through the agents. All right. I think we can go back to the code now, and let's see how we can first of all define the tools, right? Define the MCP servers for ourselves, and then how we can use them. So first things first. So if we want to define our own MCP servers, we can use the MCP SDK. It is available in multiple languages. So in this case, I'm using Python, but it is available in, I think, like JavaScript, Java. I think they recently released Rust. So we can find a lot of different available SDKs for MCP. And again, as I said, it is essentially structured inputs and outputs based on JSON RPC, so it's not very hard to implement it on your own as well. So in this case, again, I have the same bash tool, which you've seen before, right? So it basically just executes the command over here. And what I need to do to convert this code to MCP server is essentially three lines, right? So import this library, right? So and then create essentially this instance the server, and then decorate my function with this decorator, and that's pretty much it. This is what is needed to convert my code to MCP server, and then any agent can essentially use this MCP server through MCP protocol. Now, if we now want to use this with our LLMs, We can do this in the following format. So here I'm switching to Sonnet 4, just because, I mean, MCP comes from Anthropic, so I guess it kind of makes sense to switch to their model here. But OpenAI recently also adopted MCP, so it should work with GPT as well. And most of the latest models also are adopting MCP, so it's becoming sort of a standard across the industry. So I'm also using Anthropic's web search, which is essentially also kind of MCP tool, but it is remote, so it is working on their servers. Here I'm defining our MCP client, which is essentially, as you've seen from the diagram, it first queries the MCP servers, available MCP servers for the list of tools, and then it executes all the requests from the user and queries the MCP server for any tool call asked for by LLM. So it is quite long, but the main parts here are, well, as I mentioned first, we connect to servers. So we collect all the tools available from the servers. So here we get a list of tools, and we will see in a second like this sort of debug print, of course, connected to server with a bunch of tools. And then the second part of this client is processing the query, right? So there is user query over here, which is then get passed to LLM along with the description of the tools. So we pass on the name, the description, and the input schema, similar to what you've seen for create branch just a few seconds ago. And as you would imagine, if we have a lot of MCP tools, it would populate it would take a lot of the input prompt, a lot of tokens, so be careful with when using MCPs in that sense. And then, of course, we essentially query the model over here. We just send a message along with the description of the MCP servers to the model. And then, until we hit the iteration threshold, we essentially check if the model decided to use the tool or not. Now, Anthropic, I guess it makes sense since the creator of MCP, they also made sure that we can easily parse the output from LLM itself. So as you can see, LLM, the client by default defines if the response from LLM is just a simple text or if it's a tool use. So we can differentiate based on this. And then if it's tool use or if it's a server tool use, which is the case for web search, we can then execute that tool. And there are a bunch of these sort of colorful things, which we will see in a second, so you can ignore these prints. The main part, again, is we get executed tool, which was requested by LLM, right? So here we get the tool executed, and then we pass this, the result of the call of the tool to LLM. And then this loop goes again. So as you can see, we attach this again, we send this again to the LLM. And yeah, if the LLM decides that it collected enough context, if it decided that it got the answer and it gave us answer, we detect a stop sequence, right? And then this means that LLM is done, or if not, we go into the loop again. And then let's see. So the way we define how to run the servers. MCP servers, we use these JSON files. So let me open it for a second. I will run the full JSON right away. So here I'm defining three MCP tools. First of all is file system, which essentially gives access to the file system. It allows to create files, write files, modify files, delete files, and do the same with directories. There is a fetch tool, which allows LLM to fetch web pages. And then there is our bash tool, which you just seen a couple seconds ago. Now, as you can see, they are defined in this case in either JavaScript or in Python. But again, as I mentioned, there are SDKs for different languages. And you can also run those tools as Docker file, for example, as Docker image, as Docker container, for example. So essentially, it is pretty flexible. So any executable you can put here and use as MCP server. Now let's connect to our MCPs over here. Yeah, so as you can see, it got connected to 3 servers, as I mentioned, the file system, right, the fetch and the bash. And then we can do, again, a few queries over here. I'm also using the fact that latest Claude models can run tools in parallel. So in this case, I'm asking to essentially create 5 new files, and it should be able to create them in parallel, not calling tools one by one, but all in the one iteration. So you can see the loop 1, and it decided to call write file tool 5 times. So we executed this tool 5 times in parallel, and we should get 5 files in our local system. Let's see, yeah, there we go. So essentially, LLM was able to create those files, and of course, it could also modify them. It could also edit and input some code and so on into those files in parallel. See how many time we have. Okay. So one other example over here is a bit more sort of realistic, right? So we can ask the LLM to run the Docker file, which I have in this directory, and fix it if it doesn't work. Now there are a few errors in the Docker file and the code which is being run in the Docker file. So let's see if the LLM will be able to fix those for us. Looks like it's not. Okay, looks like there is some issue with the client. Let me restart the kernel. And run the client one more time. Hopefully this will fix the issue. All right, well, again, looks like, yeah, it worked again 1 hour ago. So yeah, well, all right. Well, let's, we'll see what the issue is after the call and sorry, after the presentation, and I will update the repository with the fixes. All right, but yeah, so essentially, ideally, it would be able to run the Docker file first, try to build it, and then see detect errors and fix them. Now, let's see the next evolution of this, right? So here we only had one LLM, which was able to execute tools. And the tools were essentially deterministic functions, right? So it was like file system, it was bash commands, and so on. But we could, of course, imagine the scenario where those tools are not deterministic tools, but agents on their own, right? So you can imagine one agent calling another agent, or multiple agents working in parallel, as I mentioned before. And there are different sort of multi-agent architectures where you can define how the agents interact with each other. Again, it could be sort of supervisor schema where there is one sort of high-level model, like sort of like product manager, which is working with the subordinate agents. It could be multiple agents working in parallel and interacting with each other without any specific supervision, like a network case, and so on. So essentially, it instead of LLM calling tools, it can now call other LLMs or other agents. And the tricky part here is that, as we know, LLMs are non-deterministic, right? So when we are talking about multi-agent architecture, we need to take this into account that every node in this graph, right? So every node in this graph and in this graph and so on, they are essentially undeterministic, right? So we can't rely on each node every time. And if you experienced agentic coding in your IDE or whatnot, you might have experienced the cases where LLM would get stuck. It would go into the loop over and over, trying to drop the database, start over, and so on. And obviously, in such cases, it's a bit hard to rely on the different agents. And in general, putting all the sort of multi-agent systems to production is quite a engineering challenge. Now, I will show a sort of simple example, right? So which you can use as a starting point. But again, because of the undeterministic nature of each node, it can be quite hard to put those systems in production, sort of in the wild, right? Again, because you can't you need to have a lot of guardrails. You need to have a lot of fallbacks in case one of the agents goes in the loop or introduces the wrong answer and so on, and then it sort of poisons the whole system, all the subordinates after that. And there are quite a few ways to define multi-agent systems, right? So there are a few frameworks. I put here a few, the most popular ones probably. So there is LangGraph from LangChain, which is an open source framework. There is Crew AI, which is framework under sort of freemium model. So they have an open source part, but they also have a paid subscription. And also Google, it's technically not a framework, but rather a protocol. So Google recently introduced this agent-to-agent protocol, which essentially looks similar to MCP in the sense that, unlike an MCP, all the agents are servers which advertise its capabilities, its skills, and then the client agent can call those server agents with those skills, and then act based on those skills. So essentially like MCP, but instead of tools, you now get the servers which have undeterministic response. Right? What could go wrong, right? So let's see how we can implement these using LangGraph, and hopefully this one will work without issues. All right, so we are again going one level more in terms of abstractions, right? So on top of the simple LLM calling, we now use a LangChain and LangGraph to do that. We will be using Anthropic again. So we are using Anthropic as LLM. We have the same tools which we used before. So file management. We also get the player browser, which will allow LLM to run the browser and do different stuff in the browser, like clicking around, filling the forms, and so on. We have the shell tool. We have the web search. Yeah, so essentially, this is the tools, and then we also will be using the swarm schema, the sort of LangGraph swarm framework, which is another layer of abstraction, which allows us to abstract away all the different handoffs between the agents and passing all the state and the information between them, and so on, with a nice layer of abstraction. All right, so again, as I mentioned, we are using Anthropic, Sonnet 4. We are defining the tools, and in addition to the tools I mentioned, we also are using this human tool over here, which will allow the LLM to ask questions back to us, to the user, if it decides to get more clarifications. We then define our handoff tools. Essentially, it's a way or direction for our edges in the graph, right? So as I mentioned, I actually didn't mention this, but we will be building the supervisor schema, right? So we will be using the supervisor schema where we'll have one supervisor agent, which will talk with all the other subordinate agents. But those agents, subordinate agents, they can only talk to supervisor. They can't talk with each other. So hence, we have a few handoffs, right? So we have a handoff to all the subordinate agents, right? So to backend, to frontend, to DevOps, to QA agents, and we also have a transfer back to supervisor, to product manager, over here, right? So basically, the product manager, supervisor, can transfer to all different subordinate agents, which in this case will be backend, frontend, DevOps, and QA, and they can in turn transfer back to product manager. And yeah, as I already mentioned, we have sort of agile team, virtual agile team of backend engineer, front-end engineer, DevOps engineer, and QA engineer. They all have tools, access to tools like Bash, Search, file system, Playwright, and Human. And we also have the product manager, which is essentially a supervisor of those. The prompts are pretty straightforward, right? So product manager, we are instructing to first create a plan, a step-by-step plan, and then decide which of the agents needs to execute the next step of the plan, and then pass on to that agent the task of this step. And then all the specific agents, specific virtual engineers are defined in the pretty similar way. So you are a senior backend or front-end engineer. You are tasked with a specific task, create a sub-plan for this task, follow it, execute it, and then pass on back to the product manager, right? So sort of approximating the typical development cycle. And yeah, we have front end, we have DevOps, we have QA engineer. So prompt-wise, they are not really that different in this scenario, but of course, in reality, in production, you might want to focus your agents on more specific tasks, or you might want to give them more specific tools, right? So for example, Playwright tool might not be useful for the backend engineer, but is useful for the front engineer, just because for front engineer, it might virtual engineer, it might make sense to run the website, click around, check that it works, and so on. So yeah, over here, we are defining our agents. Again, we are using the same React pattern, which you've seen before, right? We are passing the available tools, the prompt, and then to each of the agents, we are passing the tool of transferring to product manager. And product manager itself gets the same tools, plus all the transfers to the different virtual subordinate agents. And then, in the end, we are creating this swarm of agents. Our agents being 5 of those, right? And the main sort of default active agent is our product manager or supervisor. And yeah, that's essentially all you need to do to sort of create a basic multi-agent system using this land graph approach, right? So not much of the code. Most of the code is essentially prompt or prompts to the agents. And then let's give it a task. So over here, this function is just for more pretty formatting of, so you can ignore this one. And the prompt which will be given to the system is the following. So we want to build a website for the conference. It should have several pages. We should use React for the front end, Fast API for the back end, Docker, Postgres, all the typical stuff. And let's execute it and see how it will behave. Hope the internet is still working, because it's taking a usually long time. Let me actually see if everything is working. Okay, so it works. Well, let's wait for a second, because it seems like, come on. I think I might need to restart the Jupyter notebook for a second. Just a second. Let me close this, because it might be some issues from my previous test. Sorry about this. Let me restart the Jupyter notebooks. All right. Yeah, probably the most stressful part of the talk is the live demo, because always something goes wrong, even then when it worked like an hour ago. Come on. It looks like there is something actually with Anthropic. Of course, something goes up with the provider when it's, when it is mostly needed. Yeah, so of course. So let's see if we go to, come on. Yeah. Of course. Yeah, perfect timing. Yeah, so yeah, unfortunately, we won't be able to see the multi-agent system in action, and that's luckily for me, it's not my fault. Yeah, but as I mentioned, you can find all the code in the repository, so you can play around with it on your, on your spare time. And usually they do take some time, though like multiple agents, they take maybe 10, 20 minutes to create a website, but it looks usually pretty nice. So, when Anthropic is back, you can play around with it. Now, let's switch to non-stressful, non-demo part of the talk. Let me briefly talk about us, about Encoder. So as I mentioned, we are, and how we fit in this multi-agent or agentic world in general. Right, so as I mentioned, we are agentic coding assistant, and we allow you to develop your own agents right inside the IDE. So let me quickly showcase that. Let me open the VS Code over here, which is on my wrong screen. Let me move it here. Right, so basically, of course, we have a few agents already predefined, right? So specialized coding agent, unit test agent, ask agent if is when you want to talk about something, end-to-end test and so on. But the nice thing is you can also create your own custom agents. So here I have a few agents created by my colleagues, and they were shared by organization. Right, so as you can see, they were created by a few of my other DevRel colleagues, and I think a few are from me as well. So this one I didn't share. This is my private agent. So you can essentially basically create your specialized agents, task with specific tools. So you can give them a list of tools you want them to use. So for example, you can give them access to Slack, to Git, or whatever you add as MCP tools. And then you can use them either inside the IDE to do a specific task, or you can also use them in a sort of kind of multi-agent fashion if you put them inside your CI pipeline. So for that, we essentially have a few things. So first of all, you can see also the list of the agents which I have here, which you can use right inside the CI pipeline. And then we expose them as webhooks, which you can then pass to any of your IT systems, right? So in my case, for example, I have Jira, of course. And I have an automation which essentially triggers the agent to solve the task when I label the ticket with this then agents label. Once I do this, it should trigger the action, so it triggers the action. So essentially now the agent is for solving the ticket for me, and we won't be waiting. I have the sort of old pull request from the same ticket, so it solved the issue for us. It created the commit, did the file changes over here. And then another custom agent I had, which you've seen, the review agent, came in and it actually reviewed the code, right? So it did find some serious issue apparently. And then you can, of course, also use yet another agent to address those comments. So essentially, make different AI fights about the code. All right. So with all that, so let's briefly talk about the future because we have a few minutes left. So let me put this here. Now, what's next for developers? And you've probably seen a lot of different opinions about this. You've probably seen a lot of different funny or not so funny pictures or phrases. So people are saying that you won't be replaced by AI, but you will be replaced by a developer who is using AI. So there is, of course, some truth to that. But still, at the same time, even if you are vibe coding, and this is pretty common term nowadays, even if you are vibe coding, you still need to understand what's going on, because otherwise, you get a lot of potential security issues from LLMs. You get things like that, right? So it kind of doesn't really potentially lead you to be replaced, right? Now, but seriously, we as Encoder at least believe that AI is not going to will be a replacement. It will be more for a multiplier, right? If you will, it will augment the teams, the programmers, in a sense that now with the help of AI, a single person, a single developer can do much more beyond his or her own scope, right? So if me as the ops engineer, I can do, for example, front end with AI because I can I can understand JavaScript. Can't write JavaScript, so I can basically review the code produced by AI and see if it's going off, if there are any security issues. But still, me as a sort of single person, I can fulfill tasks of multiple typical cross-functional team members, right? So I can do QA. My agents can do QA. They can do backend. They can do frontend. They can do something else, and so on. And essentially, as a single person, you are becoming much more powerful and much more cross-functional. But still, this, of course, requires some understanding, at least of what's going on, to avoid the cases from the previous slide, right? And even if you are vibe coding, still you need to be able to understand what's going on, right? So, and because of that, at least for now, for the next few years, AI will be more of a force multiplier rather than replacement. But if that turns out to be wrong, of course the AI still needs a lot of data, so there is still one drop left. You can create data for AI to be able to train on. And with that, that's all from me. A few QR codes for you again. So the one for my socials and the one for ZenCoder. If you want to try us out, feel free to try us for free. And that's all from me. I will be happy to answer any of your questions. Okay, I guess, yeah. Yeah. It's available on GitHub. I can put a QR code for the repository back. 1 second. It's somewhere over here. Yes, all the code is there. You can, when Anthropic is up, you can try the multi-agent system. And yeah, I probably should have a backup with a GPT or something, but yeah. Of course, Anthropic is down at the most appropriate moment, as always. Yeah. Yeah, so I mean, it really, in general, depends on the task, on the context, right? So and the tools available for the LLM. But again, as I've shown in the one of the slides here, so you can see, for example, on this benchmark, which is considered one of the most difficult ones, as the name suggests, it's humanity's last exam, right? So it's considered to be one of the most difficult one for LLMs, for AI nowadays. And as you can see, the boost from just vanilla LLM to LLM with tools is, 30%, right? So it is quite significant, given that just vanilla LLM can barely solve anything. And when we are talking about more kind of like simpler in a sense examples, simpler queries, of course, this also gives much more significant boost because the reality is all the quality of answers is about the context you give to LLM, right? And if you want to get better answers, you need to give better context. And through MCP, through tools, LLMs can discover that context on their own, so they can decide which is needed. And this, of course, then allows them to give you better results. Yeah. Yeah. So if you're talking about the one in the VS Code, so we have, I think, the one which we have here, I think this one is it's pretty straightforward. It's just for specification for the project, right? So it can create diagrams, specifications, whatnot. But again, it's a custom agent, so you can define it to generate anything you want, and it can generate documentation for. Mm-hmm. Yeah. That's a good question. Of course, the results might vary depending on the code quality and whatnot. We actually recently had one of the clients, and actually I think I have an agent here, which converts Java 1.6 2017, which was a fun project. But yeah, of course, the quality of the results all depends on garbage in, garbage out, right? So the better your quality, the better the quality of your code, the better results. But at the same time, through the tools, the LLMs can potentially understand what's going on without actually having a non-obfuscated code, right? So they can, for example, execute the binary. They can run the tests, whatever. They can see what actually is happening, right? And then based on that, they can provide you with better documentation and maybe hopefully refactor also the code. Mm-hmm. 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 Yes, so for security in general in AI and LLMs and MCP is quite a big topic nowadays, and actually have a different talk about this. And I did not put security in this talk because there is not much time, unfortunately. And yeah, you probably heard about recent hacks for example, for GitHub MCP, all right? So where it exposed private repositories, and there are still a lot to be done in general on the AI security side. Speaking of our product specifically, we do have on-premise installation. If your company would be interested, we can discuss after the talk. Right, so but that would of course requires for you to host the models, for example, so that none of the code. All right. Well, I mean, yeah. I mean, as I said, we can discuss after the talk. All right. Any other questions? I guess not. All right. Thank you, everyone, and hopefully Anthropic will be back soon. Oh, thank you.
Question?
Yeah.
It's more, if you know, do you have direct integration with Spring AI, or are you planning to integrate with Spring AI?
I'm actually not familiar with Spring AI, to be honest. So
So there's like a new module released in Java with Spring.
okay.
Spring
Yeah, I thought it was related to Java. Okay.
and they are sort of doing